All right, here's explanation for homework for the practice problems for lesson 1 and lesson 2. Which of these shapes is not like the others? Explain what makes it different by representing each width and height with a pair ratio. And you know what I'm going to do. I'm going to make a table instead of just a ratio. So in A, if I count across 1, 2, 3, 4, 1, 2, 3, 4, 5, and I count up 1, 2, 3, 4 units. In B, I'm counting across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm counting up 1, 2, 3, 4, 5, 6, 7, 8 units. In C, I'm counting across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the height there is 6. So what I'm looking at is that which one has the similar ratio. What we're going to do to check number-wise is we're going to divide. Now you can divide either way, 5 divided by 4, but usually what we do here is 4 divided by 5. If I do 4 divided by 5, I get 0.8. If I do 8 divided by 10, I also get 0.8. If I do 6 divided by 10, I get 0.6. So I can see that the third one, shape C, does not have the same height to width ratio. So I would say that the first two are like each other and the third one is not. Question 2, in one version of trail mix, there are 3 cups of peanuts with 2 cups of raisins. So you know, again, I'm going to do this. 3 cups of peanuts, 2 cups of raisins. Who likes raisins? Yuck. In another version, there are 4.5 cups of peanuts and 3 cups of raisins. Are the ratios equivalent? Well, again, we need to look through multiplication, right? We can't say we have 1 more cups of peanuts than we have of raisins and 1.5 more cups of peanuts than we have of raisins in the second one. We need to check through multiplication or division. I'm going to divide. 2 divided by 3 gives me 0.6 repeating. And 3 divided by 4.5 also gives me 0.6 repeating. So yes, they are the same ratios. That would be the same recipe. So if I'm a store, if I'm a bakery making this version of trail mix, I know I can sell those two things as being the same recipe. We skipped question number 3 and we went down to question number 4. So for this one, I would put them both into the same units. Instead of centimeters to kilometers, let me go centimeters to centimeters. I have to figure out how many centimeters there are in a kilometer. And I know there's 100 centimeters in a meter times 1,000 meters in a kilometer, which gives me 100,000 centimeters in 1 kilometer, which means that my scale is C. Number 5 says find 3 different ratios equivalent to 7 to 3. Well, you could do any numbers you wanted there. Easy numbers, 14 to 6, or 21 to 9, or 28 to 12, or 49 to 21. I could also cut those numbers in half, 3.5 to 1.5. Those are all equivalent ratios to 7 to 3. Here's our questions for lesson 2. When Han makes chocolate milk, he makes 2 cups of milk with 3 cups of chocolate syrup. Here's a table, blah, blah, blah. And again, for this question, there was a word bank down here. Use the information to make complete the statements. Some terms are used more than once. The table shows a proportional relationship between, and I would say you could do this either direction, cups of milk and tablespoons. Here's the thing about tablespoons. You can write TBSP, or bakers use a capital T for tablespoons and a lowercase t for teaspoons. Tablespoons of chocolate syrup. The scale factor shown is, so we got to be careful here. It's not 4. We don't use the scale factor going down. We use the scale factor going across. And again, we find that by doing the right value divided by the left value. So our scale factor would be 3 over 2. The constant of proportionality, that's where the 1 is located in the table. It's also 3 over 2. The units for the constant of proportionality are 3 tablespoons of chocolate syrup per cup of milk. fit that on the line, but you guys can. All right, the bottom one. A certain shade of pink is created by adding 3 cups of red paint to 7 cups of white paint. How many cups of red paint should be added to 1 cup of white paint? So this is that constant of proportionality, where that 1 is in the table. That means no matter what is happening down below in the table, it means we're multiplying by whatever that number is to go from here to here. Well, how do I find that? I go the opposite. I divide here to here. Now we could do that as a decimal, 3 divided by 7, and you'd get a decimal. Or we could just write 3/7. 3/7 means 3 divided by 7, and we're done. Okay, if you want to turn that into a decimal, that's okay. Just be careful because it is a repeating decimal, but it doesn't repeat for a long time. I think it's 0.42857142857 keeps going on and on and on after a long time. Sometimes the fraction is more convenient to write than the decimal. And when we go back to that table, it's this number. It's whatever number is next to the 1 in the table. Question B here says, what is the constant of proportionality? All right, next one I think we did together in class. So I'm going to skip number 3. Select all the ratios that are equivalent to each other. So here again, I would divide this divided by this, this divided by this, this divided by this, this divided by this. I think there are 2 that are equivalent to each other, and those would be A and C. If we divide, we get the same thing each time. Oh, and there's an E. E, I believe, also included. My pages are a little different from yours. All right, so that's lessons 1 and 2, the answer keys. And next video will be the answer keys to lessons 3 and 4 practice problems.